All right, so first question we're going to look at is finding the formula for an arithmetic sequence. So the first thing we have to recognize is what is the first term and what is the common difference. Okay, what's the first term in that sequence? Yeah, 5, yep. And what is it that we're doing, we're adding each time to get from one term to the next? Yeah. 3. Okay. Now there's a formula we can plug into. It starts out a sub n equals. And does anybody remember what the formula is from Monday for finding the terms in an arithmetic sequence? Yeah, go ahead. Joe, you think you got it?
A to n is A1 R to the n minus 1.
Say it again. A sub 1. Yep. Yep.
Is it a n minus 1 with d after it? That was a guess off of memory.
No, we don't want to do a recursive. We want, I'll just add this in. Find explicit. Find an explicit formula for the sequence. So what's the formula that we want to use?
K1 plus n minus 1 times d.
Yep. So now if we fill in the first term, we get 5. N minus 1, we just leave that the way it is. And then d, we're going to fill in 3. What do I get when I distribute out my 3? Yeah. 3n minus 3. And combine all your like terms. And what will that give us for a final answer? Yeah?
3n plus 2.
3n plus 2. And we can check it. This was the first term, second term, third, and fourth. If we plug in the position, it should give us the value. So if we plug in 4, 3 times 4 is 12. 12 plus 2, 14. Perfect. Okay. So that is the formula we were looking for. Okay, so the next question is asking if the sequence converges or diverges. So converges would mean as we continue to write the terms out, we're getting closer and closer to a value. All right. Whoops, let me fix that one. Sorry. Let's look at the first one. 60, 30, 15, 15 halves. What's happening each time? Yeah.
It's getting split in half.
Yeah, it's getting split in half. So are the terms in this sequence getting closer to a certain number? What do you think, Joe? Right, so they are, this is converging. So it's definitely converging because the terms are getting closer to a number. And now when it says find the limit, that's when you tell me it's converging to the number 0. Because if you keep writing these terms out and you keep taking half, they're going to get close to 0. How about this one? 4, 6, 8, 10, 12, 14. Is that sequence converging? No. What are we doing each time? Yeah, an arithmetic sequence never converges. Because with arithmetic sequences, you're just adding or subtracting the same number repeatedly. That can never converge. Geometric sequences are the only kind that can converge. Okay, so in this case, this diverges. Okay, so here's a problem where we're writing out the first 5 terms of a sequence. The top formula is recursive, the bottom one is explicit. So these are 2 separate questions. In the top one, what is going to be the first term in my sequence? Yeah.
3.
How come?
Because it's given.
It's given. Yeah. And now, what does this rule tell me to do? I know the first term. This explains how to get the next one. What is that telling me to do? Yeah.
It's telling you to plug in 3 for the A, and then the N would be the number. Oh wait, no, it's telling you to plug in the number that you're looking to get every time you put the A in.
If you have 2, you plug in 2 minus 1, so that's A1, so that would be 3 plus 5.
Okay, so how would you find A2? What would you do to get A2, which is the second term?
You add 5.
You add 5. So A2 would be
8.
8. How about A3?
11. Oh, that's fine. 13.
13. And A4?
17.
15. Wait, you're adding 5. 4 minus
18.
Well, when you do A4 minus 1. Yeah.
So you're adding 5, so
You're
it's
adding 18.
18.
Yeah.
Yeah. And then the last one? 23, yeah. So there's the first 5 terms in the recursive sequence. Any question on that? All right, the bottom one is explicit. Okay. They didn't give me the first term, so you have to find it. With explicit, they don't need to give you the first term. That's all they give you. How do you get the first term using that formula? Joe?
Substitute.
Yep, substitute 1 in where you see n, and if you plug in 1, you would get 6. How about the next term? Yep, it would be 8. And the third term? 10. And the fourth term?
12.
12. And for the fifth term, you're plugging in a 5 for n.
Yeah, 14.
14. So that's writing out the first. I could ask for the first 5, for 6, something like that. Any questions on that? Okay. All right, so this one, they want us to find an explicit formula for the sequence 4, 12, 36, 108. So we already did one where it was explicit, and that was the first example. This one's not, I'm sorry, arithmetic. This one's not arithmetic. What kind of sequence is this one? Yeah?
Geometric,
Yeah, and how do you know that it's geometric?
because they're multiplying by 3 every time.
Okay, so you are multiplying by 3 each time. So now we know that is our R value. That's the common ratio. And the first term in this case is how much? 4. So there's a formula to calculate the nth term. And it's like the one we did on the first example, but this is now for geometric. Anybody have that formula? Yeah?
I think I have the one for sums, actually. What was A1 minus R? So N minus R?
So it does have A1. That's the first part.
Yeah.
Yep. So what's the formula again, Joe?
A1 times R to the n minus 1.
Yep. That's the formula to calculate the nth term of a geometric sequence explicitly. So what's the first term in this one? 4. And what's our R value? 3. And that is the formula
Oh, and you can't combine.
that we calculate the nth term. Yeah, and we can't combine that because the 4 and the 3 are different. All right, so in this one, we are looking at a series. So now we're not just plugging in a number for k and writing down the answer. We're plugging in a number for k, writing down the answer, plugging in another number for k, and then adding them all together. In this case, we'd be adding up to n terms. So, based on this formula, what kind of sequence are we adding up? An arithmetic sequence or geometric? Yeah.
Geometric?
Yep, that's the formula for a geometric sequence. And the symbol means add it all up. What is the first term in the geometric sequence of numbers we are adding together? Yep, 4. Yep. And what is the R value in this geometric sequence? Yep, 1/2. What does the R value have to be between for it to converge? Yep.
Between 1 and -1?
Yep, between 1 and -1. Is our value between what you just said? Yeah, so this will converge. So that's the first part. It does converge. Now, I want to look at what would happen if we added up all the terms from, you know what, let's not go to n, let's go to infinity. If we just added up all the terms forever. All right, what's the formula for adding up an infinite amount of terms in a geometric sequence? Okay, so what's our formula we're going to use to add up all the terms in this sequence? Yep. So wait, what goes in the top again? I think Natalie just said it. No, that's for finite. So Natalie, what goes in the top there?
A1.
A1.
So 4.
And what goes in the bottom?
1 minus R.
1 minus r. So this is the formula you use when n approaches infinity. Okay, so the first term is 4, and our r value is 1 minus a half. Okay, what's 1 minus a half? Half, and what's 4 divided by a half? 8. So if you were to add up every term in this sequence to infinity, it would approach 8. Would it ever reach 8? No. So it converges, and the limit is 8. Okay. So next thing we want to look at is writing a finite sum in sigma notation. So when we write something in sigma, we need to know where we're going to start and where we're going to stop, and we need a formula. You're not going to be able to figure out your starting and stopping point until you know your formula. So the first thing is I would label these like this. We don't know that last one, however many down that one is. But we've got the first 5, and we want to figure out if there's something we can do to this number to turn it into that number. So does anybody see what the pattern is for that one? Yeah, Joe?
2n plus 1.
Yeah, the formula is 2n. I'm just going to change it to a k because when we do sigma notation, that's the letter they use. So it's 2k plus 1. What number would you plug in for k to get that right there? Yep, so you're going to start at 1. And what number would you plug in for k to get 33? 16. So that is how you would express this in sigma notation.
If we have one of those in the test, is it going to be like multiple choice, or we have to type it?
It could be multiple choice, or it could be one where you have to fill in, like there's, what I would do is have a sigma and then put a blank box over here and a blank box up here.
All right.
And you'd have to fill in the blank boxes. Yeah. So you could get partial credit if you get, there'd be 3 boxes. Or if I give you one, maybe I'll tell you to start at 1. Okay, so this is a problem where it's a finite sum. So you're adding up all the numbers in this sequence. They've given you enough information that you should be able to figure out all the terms that you're missing. There is a formula to do this. We didn't learn the formula, so you're just going to have to do it by hand. Right? So just add them all together. So first thing would be to at least fill in the terms that you are missing. So 3, 6, 12, 24. And what's happening each time?
Multiply by 2.
Yeah, you're multiplying by 2. So we've got 48. We've got 96. And then we just need to keep multiplying by 2. So we got 192, 384. And then the next one would be 768. So the only, not even that tricky part was you had to figure out what the dot, dot, dot included. Okay. And now you just add them all up. 3 plus 6 plus 12, 24, 48, 96, 192, 384. As long as I didn't make a mistake, it should be 1533. Now, if you had to do that for maybe like a couple hundred terms, we would want to figure out a formula. And because there's a pattern to what we're doing, actually no, I think we did learn the formula for that one. But anyway, there was enough terms that it was small enough. We could just do it by hand. But yeah, you're right. We did do a formula for that one. But any question doing it that way? Okay, so evaluating a factorial. What does 8 factorial mean? Yeah?
Isn't it you're adding all the numbers from a given number to 1? Oh, it's multiplying.
It's multiplying, yes. So it's 8, 7, 6, 5, 4, 3. Or you can stop at 2 because times 1 doesn't really do much. So it's the product of every number from your number all the way down to 2. So you can type that in manually or on your graphing calculator, on all your graphing calculators. You can type in 8 math and it's under probability, and that's where you can find the factorial symbol. If you ever can't find something, you can always press second catalog, and there's an alphabetical listing of every single function that the calculator has. If you go up, symbols are at the end of the alphabetical listing. I don't know how they're sorted, but somewhere in there, if you kept going, you would eventually find an exclamation point. But I'm not going to keep going because this takes, there it is. So it's the very first symbol after the functions in the calculator. All right. Any question on how we got 8 factorial? Okay. Okay, so this one they want us to find a single number that would be in front of this term in the expansion of that binomial. When you expand x plus y to the 15th, how many terms do you get?
16.
You get 16. You don't really have to make a chart. But if you want to get a visual of where you're going to be, x to the 12th y cubed. What would the power of x be on this first term? Yeah,
15,
this would be x to the 15th, and then x to the,
14, 13, 12.
there we are. So that's the term I'm trying to have you find. The number in front of x to the 12th, y to the 3rd. Now, there's no other numbers with the x and the y here. So when you do the expansion, the coefficient is right from the triangle. It's not like it's a 2, it's not something like that. That would complicate it a little bit. What row in Pascal's triangle do we need to look at?
4.
Oh,
Hmm?
No, not
No,
the fourth
12.
row.
And then 4.
What tells you the row you're looking at? There's a number there that tells you. Yeah?
is it the coefficients? In this case, there is none.
Well, yeah, there's no coefficients there. We just have a bunch of ones in front of these.
So is it row
Well, you're looking for a row in Pascal's triangle that would have 16 numbers in it.
1? Oh, it's row 15.
It's row 15. Yeah. So we're looking at row 15. And what column are we looking for?
Please excuse the interruption.
But what column is the fourth number in?
Oh.
The fourth number in the row is not in the fourth column.
Is it in the third column?
It's in the third column. So if you wrote out
You
Pas-
start from 0.
you start from 0. So if you were to write out Pascal's triangle, you're going to row 15, column 3. That's the number that I'm looking for in this problem. But now we have to figure that out. Okay, row 15, that's a little too high to write out by hand. So we have a formula that allows us to evaluate a binomial coefficient. What's the formula? Yep.
Is it n factual? Is that what you're
N factorial.
Oh, n factorial over n minus r factorial r factorial.
Yep.
Yeah.
Or if you don't want to say it that way, you can just say n over n minus r times r. You could say it that way too. But the factorial is helpful to remember what it does. So now, what would go in the top?
Factorial.
15 factorial. And what would go in the bottom?
15 minus 3 factorial.
Which is
12.
12 factorial times
3 factorial.
3 factorial. Okay, now you can completely cancel 12 factorial into 15 factorial. If you do that, what's left in the top?
15 times 14 times 13.
15 times 14 times 13, so now the 12 factorial is gone. And what's 3 factorial mean?
3 times 2.
3 times 2, and keep reducing. 3 goes into 15,
1 and
5, and then 2 goes into 14,
1 and 7.
7. And now we have 5 times 7 is 35. And we need 35 times 13.
455.
455. So that would be the number then in the, that's the coefficient of x12 y cubed. Now, at first you had asked me for the, I think you said the 12th column. You could actually look over here and get the same answer. 1, 2, 3, 4 in on the left. 1, 2, 3, 4 in on the right. That number is the same. Because remember, the triangle is symmetrical. So once you could find that number, and it would still come out to
The
455.
coefficient would be the same, it just wouldn't be the same
Yep.
exponents.
That would be row 15, and that would be column 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh yeah, it is 12. Yeah, I guess it is. Yeah, I think you had said 12. But I really wanted you to say 3, because that's really the one I'm looking for. That's the mirror image of the one I'm looking for, but it is the same. Yeah. Okay, any question on that? Okay, so the last one we're going to look at is expanding a binomial. Remember this, we don't want to do it out by writing 3x plus y 4 times and foiling it. We want to try to use Pascal's triangle and the pattern. So what is the row in Pascal's triangle that we are going to need? Row 4. And what are the numbers in row 4?
Four, 16,
1, 5, 10, 10, 5, 1.
How about the row before that?
1, 3, 3, 1.
And the row after that?
1,
Four,
6.
six.
What is it?
1, 6, 15, 20, 15, 6, 1.
Nope, there's a row in between.
4, 6, 4.
What is it?
4, 6, 4. 1, 4, 6, 4. 1.
1, 4, 6, 4, 1. Yeah. I think we lost a row there.
I think I did this around.
1, 4, 6, 4, 1. It should be a row with 5 numbers. It has to be 5 numbers because we're raising to the 4th power. Okay, so first coefficient is a 1. And then what would we have next to that? Yeah,
3x to the 4th.
3x to the 4th. We don't have to worry about the y yet because that's not part of the expansion. Okay, what's our next binomial coefficient?
4.
4. And in parentheses next to it,
3x to the 3rd.
3x to the 3rd
That's y.
times y. Okay, next coefficient,
3x to the 2nd. Well, 6.
6. Yeah, that's the coefficient. And then 3x to the 2nd,
And then y to the 2nd.
y to the 2nd. Okay, next coefficient,
4.
4.
And then 3x to the, no, just 3x.
Just
and
3x.
Y to the 3rd.
Y to the 3rd. And last coefficient,
6y to the 4th.
um, where'd you get the 6 from?
Oh, no, just 1.
Just 1. So yeah, just a 1. And then y to the 4th. Okay, now we do all that out, and then that's our final answer. Okay, what's 3x to the 4th?
9x to the 4th.
So
Oh, no.
no, 3
That would be squared.
3 squared
It
squared.
would be 81.
81. So 81x to the 4th. All right, now let's do this part first. What's 3x cubed?
27. 27 x cubed.
27x cubed. And what if you multiply that by 4?
108.
108 x cubed. And anything else we got to put with it?
Y.
Y. Okay, how about the next one? Yeah,
54x squared y squared.
perfect. 54x squared y squared. Okay, and the next term,
12xy cubed.
12xy cubed. And the last term, there's never really anything to do with that one. So if you were to FOIL that out and expand the whole thing, that would be the result. Any questions on that one? Yes?
On the 12x y to the 3rd, why didn't you use the 3 to the power of 3? Oh, since on the y. Oh, okay.
That's a 1.
Yeah,
Yeah.
I got you.
Yep. And that's it. That's the expansion.